Hello, this is Nicholas from Silicon Chip Publications, and I just want to talk to you today about the February issue, which is about to go on sale as I'm recording this at the end of January 2026. And you can see on the cover here we have an internet radio project article on the history of Intel, DCC remote controller for model railways, and other stuff. And if you look at the contents page here, you can see there's a lot more in the issue. There's an article on power electronics, part of a series. It's the fourth part, the third and final part of how to design PCBs, review of a tiny QR code reader module. And then we have 4 projects: the mains LED indicator, the internet radio that we saw on the cover, mains hum notch filter, which I've talked about previously in detail, and the DCC remote controller. Let's go through them. I'm not going to go through every article in the issue. There are some that I'll just skip, like a mailbag, circuit notebook, serviceman's log, and Ask Silicon Chip, and I'll just look at the major articles. So the first one is this history of Intel. This is a 3-part series because there's a lot to talk about Intel, and here we started with the early days, the founding of Intel, their history of their processors, which are probably their most visible product, SRAM and DRAM, some of the early computer chips, the early computers, and the advancement in the manufacturing process over time. A bit more information about how the computer CPUs evolved and became more complex over time and faster. The microarchitecture, which is sort of the design behind the chips, because there are several generations which are similar and then they'll switch to a new architecture. Some more later chips, 286, 386, etc. And then we finished the article at the 1990s, which is where part 2 in the March issue will pick up. Moving on to the next article. This is our first project. It's a very simple one. And it's basically just a question of, if you want to replace a neon lamp, which can run pretty much directly off the mains with a resistor, with an LED, how do you do it? And it's a pretty straightforward circuit and circuit board to allow you to power an LED from a main supply. The one trick is that it does need to be installed by an electrician because it has to be hardwired to be safe. But otherwise, there's a simulation of how the circuit works and an explanation. And then if we look at our next article, this is series on power electronics. It's going to have about 7 or 8 parts. Now we're up to the 4th part about rectification of AC to DC, which turns out to be a bit more complicated than you might realize, because of course we do it all the time, but we are converting a sine wave into something more like a square wave. So there are some things to consider about whether you have inductance. And we're talking about half wave versus full wave rectification, power factor, full wave rectification, and some more of the nuances about filtering and rectifying AC supplies. There's a lot more to it than you might realize. So we have a few different configurations and we talk about the differences between them, etc., including active rectification with SCRs, which is how very high power devices usually do it. Some more details here, talking about 3-phase as well. Sort of a very comprehensive article on rectification. And then our next article is a project, the internet radio. This is electronically quite simple. It uses a Raspberry Pi with a screen and an amplifier and some speakers. It's kind of like a 3D printed boombox, basically. So for people who miss boomboxes, which are not really a thing anymore, you can make one yourself for the Raspberry Pi, and you can do things like stream audio off the internet, playback from an SD card, etc. He's done quite a bit of work to make it easy to print, although it does take a while. And here's some information about, well, this is setting up the Raspberry Pi, because you have to install some software and set it up. But it's all sort of off-the-shelf software that's pretty easy to do. Here's a diagram of how the connections are made, list of parts that you need to build it. So that's a 2-part article because there's quite a bit more on the mechanical aspect of it that will be covered in the second part. Moving on to the next, this is the one I've already talked about in detail, the notch filter, which is used to remove hum or buzz from an audio signal if you can't remove it any other way. And it's kind of an interesting circuit with a particular kind of notch filter configuration in it. I won't talk too much about that because I already have. Then we have this DCC remote controller. So we've had a series on DCC, including a decoder, which is the thing that goes in the model train that receives signals, the base station, which powers the tracks and sends the signals, and now we're adding a remote controller, which can connect to the base station. In fact, you can connect several if you want, and it lets multiple people control trains on the same set of tracks at the same time using their own personal controller. So here's the back of the board. You can see it's pretty straightforward. There's a microcontroller, some buttons, a screen, some RJ45 surface mounting sockets to connect to the base station and to other controllers, and then a few controls and passives. We have a kit available. In fact, we have kits for the entire DCC series, so you can build your own model train control system using these kits. The decoders, base station, remote controllers, and there are going to be more parts later. There's going to be a booster, reverse loop controller, and a smaller decoder as well, and possibly also some accessory decoders. So here's the circuit. As you would expect from the board, it's pretty straightforward. Details on how to build, where to put all the parts, etc. And there's a couple of different options there, depending on whether you're using a surface mount or through-hole LED. Parts list is later on. Here we go. The parts list, some information about setting it up and using it. And then if we move on to the next article, this is the last article in our three-part series on designing circuit boards. So this talks more about actually getting a PCB that you've designed, manufactured, and even assembled. So we have some example here of you can now get a full color silk screen printing on your boards if you want. Talk a bit about edge connectors, thicker copper, some things to watch out for if you're going to get a PCB assembled. In this case, they put the capacitor on backwards, even though the preview looked correct, which apparently can happen. You have to watch out for it. And then we go into some detail here about a bit more advanced design techniques like differential pairs, net classes, getting a PCB assembled for you, contract assembly, the PCB manufacturing process, and some examples of actually ordering assemblies and getting them back. And then we have this article on the tiny QR code reader module. The low-cost module has a Raspberry Pi chip on it, and it's pretty easy to use. You point it at a QR code and it just gives you the data back basically over a serial port. We have some information about QR codes there. That's pretty straightforward. And then we have our vintage radio article on this Columbia TR-1000 6 transistor radio from 1950. No, it's not from 1954. It's 1957. So it's one of the earlier transistor sets, but it's not the earliest. It's kind of an interesting looking set. I remember these when I was young. These old leather cases were pretty common. Here's the circuit of the set. It's a pretty standard configuration. Looks like there's a mixer oscillator, couple of intermediate frequency gain stages, rectifier, volume control, audio preamp, and then a transformer coupled Class B push-pull pair driving the speaker or earphones. But it's a nice little set. This is at the stage where transistor radios were pretty well known, understood, and was really just a matter of each manufacturer trying to provide the best features like compactness or sound quality. So that's all I'm going to talk about. As I said, there are more articles in this issue. There's a serviceman's log. There's some letters from readers. There's Circuit Notebook, a couple of interesting circuits there. But anyway, that's the February issue. By the time you watch this video, it will be available in Australian newsagents and probably in New Zealand not long after. And you can also subscribe anywhere in the world just about. Hope you enjoy that and enjoy the magazine. Thank you.